Hello, in this video I'm going to talk about polymerisation for AQA GCSE Chemistry specification 4.73. So, polymer, really simple, it's a long molecule. It's a long molecule with a lot of repeating little bits that get put together. There's two types of polymerisation. That's the making of a polymer. The first one is addition. Whenever you see the word addition, in chemistry anyway, you want to be thinking of alkenes. So here's an alkene, and addition polymerisation is as simple as it sounds. You simply take some alkenes and you add them together. Hopefully you remember that alkenes, they react at the double bond. So all of the single bonds are unreactive and they stay the same. So the first thing you should do, if they give you the alkene in a strange shape, set it so that you've got the double bond in the middle and it makes like a capital H. I appreciate there's lots of H's there, maybe that helps you to remember it. Then you draw the shape of the H again, but I've broken the double bond. That's the reactive one. And what happens is if you break this double bond, then you end up forming a new bond to the next alkene molecule to the right, and then to the left the same thing happens. So this bond would break and there would be another bond starting to form to the right here, and there would be another bond starting to form to the left. You put brackets around this whole thing because this is going to be a repeating pattern. So if I show you here, here are two of our starting alkene, and what would happen is this bond is going to break and form a new bond in here, and this bond is going to break and form a new bond here, and for my molecule I haven't drawn, there's another one forming there. So we end up with the same 4 carbons going along, and all the hydrogens are still in place, but there would have been bonds continuing. So if I'd drawn 7 of these, we'd end up with, well, 7 times 2, 14 carbons. Now this all gets really repetitive, and this is where these brackets come in. Instead of just doing a small number, you put n, which can mean any number, and you put it down at the bottom of the brackets. So if that was 4, then you do 4 times that. Don't worry about what happens at the end of the molecule. That's well beyond the GCSE specifications. So what we're going to do now, here is another alkene. Now this one had just 2 carbons, so this one was ethene. This one, I'm giving you an extra carbon. If you want to try and think about the name just for a moment, do so. Hopefully you got that that was propene. So I'd like you to pause the video and try and get what the polymer looks like for propene. Okay, so you keep the shape of the capital letter H, and you put in all of the single bonds. Now I've kind of cheated here, I drew it as CH3. I really should have drawn them all in, but I was trying to save space. You then have bonds continuing, you put the brackets, and you put an N. So if you got that, well done. So what about naming these things? Well, this was ethene, so the polymer from ethene becomes polyethene. Poly just means lots of. So this one, if we had propene, then this will be polypropene. So again, that was propene and that was ethene. And the single alkenes, the word for them, they are a monomer, which is mono for one, poly for many. So I'm going to give you another question to try. I am going to draw the repeating part of a polymer, and I would like you to pause and then try and figure out what the monomer would look like here. You do not need to worry about naming this one. Okay, so hopefully you gave a shot at that. When you see these sorts of polymer chains, you know that it had to have come from an addition reaction, which means it had to be an alkene, and so you simply take the 2 carbons, put them in the middle, reform the double bond, and you would have had a chlorine there. I'll give you one more to try. And again, I'm going to be a little bit space saving and lazy. You could draw these out fully or not. So pause this and see if you can work out what happens and if you can name it. Okay, hopefully what you did. Again, I've already put it into the capital H for you. So it continues on. And everything that isn't the double bond stays in exactly the same place. So we end up with the hydrogens in the top left and the bottom right, the CH3s in the bottom left and the top right. There are n of them, so there had to be n repeating units. And this has got 1, 2, 3, 4 carbons, so bute is the number for 4, and that's what we get there. Okay, one final version of this for you to try. And I'm going to put a little bit of a twist in it. Hopefully you'll be able to spot what to do. I've been a little bit mean, I do apologise. See if you can figure out what to do. Right, so hopefully you've realised that I haven't put this in the shape of the capital letter H. We need to do that first, and it's always the double bond. In our molecule here, there's the double bond, and the one on the right, the carbon on the right, has just 2 hydrogens, so we'll do that. Going up, there is a hydrogen, and then we would want to turn this bond so it's going straight down. Now, you can see here there are 2 carbons, so I can either draw the 2 carbons exactly like that, or I can call that C2H5 because that's simplifying that down. You're allowed to do that. Now you would need n of those. Again, if you want to pause again and see if you can get the polymer, do so. Okay, so we have everything staying the same from the single bonds. Apologies, I got a bit excited. I've already drawn the single bond continuing, the other single bond continuing, brackets around it, and an N, and this is another version of butene, so this is another version of polybutene. Okay, so that is addition polymerization. The second type is only for higher tier. So if I lose a few people from the video, thank you for watching the addition polymerization. Condensation polymerization is from something called a condensation reaction. And if you think about condensation in the rest of the world rather than the chemistry lesson, you hopefully think about water forming on a window. Well, condensation reactions, they have a byproduct of H2O. And hopefully you can remember this one type. This is the main one that you're likely to find out about. It's a polyester. So if you see polyester words, you know it's condensation. If it's a polyalkene, it's addition. Now, a recap here on esters. There's a full video about them, so don't worry if you feel I'm going too fast, you can look at the other video. To make an ester, which are the lovely smells, you take an alcohol and a carboxylic acid and you react them together and you get the ester in the water. So I've drawn an alcohol and I've drawn a carboxylic acid. First thing, we want to get the water. The reactive bond of the alcohol is the OH, so you break that, and to get our H2O we need to rip that out of the middle. So that is H2O, and then the ester, leaving everything else the same. That's the parts from the alcohol, and this is what we have from the carboxylic acid. So this bit here is an ester link. A polyester is something which has got lots of these links. And there's some chemicals that you really don't need to worry too much about the name, but there's a thing called a diol, which means it's got two alcohols on it. So you could have, taking the chemical that we had up there, and instead of having a hydrogen on the left, you could have another OH. And so it could make an ester on the right, and it could make another ester on the left. And then if we had a clever chemical that had not just one of the carboxylic acid groups, but two, you could then have a ester on the left and an ester on the right. The best news when you draw these is they're going to put a little box in the middle that basically ignores everything else that's in there. And so what happens is each time you are going to remove water because it's condensation. So when we put these together, in fact, if I call that A and that B, so you can see where it's been different. We have our A, and then we end up with that ester with the OCO. And that is us, because I'm going to be removing at this end to make water and at that end to make water. So that is the repeating unit part of it. So you would have this and it would be going on and on and on. I'll show you here. You would have the next A, and then you would have the next B, and then you would have the next A, and then you would have the next B, and it would just keep going on and on and on. You see there's a repeating pattern where it goes A, B, and you've got these ester links. So what it would look like in practice is that you've got N, like that, and N of the carboxylic acid one. Now if they don't put A and B, they might put something similar in the exam, something completely odd to try and freak you out. Don't panic about it. You just know that that bit's irrelevant. You just need to get to this ester link. So N of those and N of those is going to give you N A with an ester with a B like that, except we then put the little N down there, and then the trickiest part, two esters, 2N waters. If you followed that, I'm very, very impressed. Have a rewatch, see what you can do, but that is one of the trickiest parts of the organic chemistry and it's higher tier only. Thank you.